Hello friends, welcome back. I'm Rajneesh and let us continue our session with the labs on Red Hat Cluster Suite. So we have three networks. One is SAN 0 which is 10.0.2.0/24. This is SAN 1 and this is BR 0. So SAN 0 and SAN 1 are the networks which are used to reach to the same shared LUN. So actually we are using multipathing on it to reach to this network or the shared storage. So finally the third interface is the actual interface that will be used for the interaction between the clustered nodes, the base machine and the Luci. Luci is a web interface that is used to manage your clustered nodes, their configurations, to reboot a node, to fence a node. So this is basically an admin interface. You can do the same set of commands on these clustered nodes also, but Luci provides a good UI to manage these clusters nodes. So in case you are new to the cluster, the best thing is you want to understand it, you can start with the Luci web interface so that you can understand the concepts better, and we are going to do the same thing in our lab. So this is the base machine on which KVM server has been installed. You need to install a few package QEMU KVM should be present, and libvirtd should be installed and should be running, and virt manager should be installed on it so that you can manage your virtual machines using GUI. So coming on to the lab. Okay, so here are the three machines that I was talking about: Luci, the web interface or the admin server. Node 10 is your first clustered node, and this is your second node of the cluster. So node 10 and node 20 are going to work as a cluster node. Luci will be used to admin these clustered nodes. Okay, so first thing you need to do is you need to make sure whether the connectivity of these three devices is working fine. So let's log in into the base machine or your SAN server. Ping 192.168.1.10. This is node 10. Connectivity is fine. Node 11. Connectivity is fine. And this is Luci.15. So if we talk about the network BR0, that is working fine. Coming on to the SAN network, SAN 0 network, ping 10.0.2.10 works fine. 2.11 works fine. So the SAN connectivity on SAN 0 interface is working fine. 3.11 works fine, and 3.10 works fine. So finally your SAN 0 and SAN interfaces are also working fine. Your 192.168.1.0 network is working fine. Okay, if you want to set up the same kind of scenario at your home, what we can do is I can show you the bridges that I have created. brctl we have one bridge BR0 which is on network 192.168.1.0. This is SAN 0 on which node 10 and node 11 are connected. Actually node 10 and node 11 have three interfaces. One is connecting to bridge 0, other is connecting to SAN 0, and the third one is connecting to SAN 1. If we have a look into the command if config, you can see three interfaces: ETH0 connecting to 192.168.1.0 network, ETH1 connecting to 2.0, and ETH2 connecting to 3.0 network. The same is happening with node 11. But for Luci, we need actually only one interface. We have attached all the three interfaces. We actually don't require these two interfaces, because it needs to interact with your nodes over the network 192.168.1.0 only. So finally your connectivities are fine. First thing that we should do is we shall create an iSCSI target on it. Service is not running. So TGT is already configured on the base machine, and I think we already had a lab for how to configure an iSCSI target. So this is actually the same approach. The backed device that is attached to it is devvg0 scan san, and the size of which is 2 gigs. So iSCSI server is fine. First thing that we need to do from the nodes is let us scan this learn. So iSCSI, you need to install the packages iSCSI Initiator Utils, and the same needs to be done on node 11. Yum minus y install. So it's not going to confirm from us, that's why we are using y. iSCSI Initiator Utils. I think, yeah, I didn't mount the CD. So now node 10 and node 11 are ready to be configured as iSCSI client. Let me start the iSCSI service, and before that let me correct the initiator names. Initiator name.iSCSI, let's just modify it to suit our environment. 2013 March, and this is node 10. Node 10. Each iSCSI initiator should be having different name. Let's modify the same in node 11. uh, okay, let's copy it, or coming on to this vim slash etc iSCSI initiator name 2013 March, node 11. So now let's start iSCSI D on both. Let's force start it. Because till now we haven't logged into any of the iSCSI learns, so that's the thing we had to restart in force start mode. Now let's try to scan the iSCSI target. iSCSI adm minus m discovery db minus portal, the name of your iSCSI server or iSCSI target server. Sorry, it's 10.0.2.101 minus discover. So what we are going to do is we are going to discover the iSCSI target on the interface 2.101. SCSI minus m discovery db minus portal. Portal not needed or possibly missing. Okay, we are missing the type. minus minus type send targets. So let's log in into it. iSCSI ADM minus M node minus T target name, IQN dot 2013 03 dot local dot labs san dot target 1 minus L to login into it. So login into this is successful. Let's try to discover it on SAN 1 interface, which is 3.101 minus minus portal 10.0.3.101. So here the login is successful. Fdisk minus L. Now here you can see that there are two devices, dev SDA, dev SDB. Okay, let me just fdisk minus L dev SDA. Before that, I would like to show you that we are not using SDA to install the operating system on it. Rather, that device on which operating system is installed is VDA. So fdisk dev SDA print and write fdisk minus L dev SDA and dev SDB. Now both of them don't have anything inside them because it was the same LUN and I removed the only partition from it. Fine. Let me do the same kind of scanning on nodes 11. iSCSI ADM minus M discovery DB minus minus portal 10.0.2.101 minus minus discover, and we need to specify type also, minus minus type send targets. Now let's log in into it. iSCSI ADM minus M node minus minus portal 10.0.3.101, the IP address of iSCSI target SAN SAN 0 interface, and the name of the LUN IQN dot 2013 3 local dot labs uh, minus L to log in into it. Now let's scan for the SAN 1 interface and log in into it. This time we are going to modify the IP address to 10.0.3.101. The name is going to be the same because we have the same LUN. Okay, so till now we have logged into the same LUN using multiple paths on both node 10 and node 11. Let's switch on the services chkconfig iSCSI on and iSCSI d on /etc init.d iSCSI on, sorry, service iSCSI on, sorry, chkconfig iSCSI on and chkconfig iSCSI d on. Now iSCSI client is ready at both the ends. Your LUN has been imported and is visible as SDA and SDB. Now, as we have used multiple paths to reach to the same LUN, we need to configure multipathing also. So let us install device mapper multipath on both the clustered nodes. Now, after the device mapper multipath has been installed, we need to configure it. So, default configuration can be seen at user share doc device mapper multipath.conf. We are just going to copy it to /etc, and the same we are going to do for node 11 etc user share doc, or the other thing is, let's prepare multipath.conf over here. Default options, let's just comment it, uncomment this udev directory /dev polling interval, the duration after which we have to check whether the path is working fine, that's 10. Selector, actually it's a bug, we need to make use of path underscore selector. Path grouping policy is multibus, so we have all the paths with the same path priority under the same path group. Get UID, how to do a UID call. What's the path? Lib udev iSCSI ID, udev iSCSI SCSI ID. So there is one option that, yeah, replace white space. So this is the function that is going to be called to find out what should be the name for which this multipath device should be created. So it's replace white space. In case we are using it without replace white space, it displays you the name with the white spaces that are going to be replaced with XXX when you create the dev mapper device corresponding to multipath. So what we have modified is just making use of replace white space, and here it is. The format will be good, will be replaced by underscore, so your device will look better with the name that will be allocated to it. So replace white space, priority constant, that is priority 1 will be assigned to every path. Path checker, check out for the first sector on it. In case that can be read, it's okay. In case that cannot be read, the device is not accessible. Maximum number of file descriptors, round robin wait, fail back, for how much delay should be there before it fails back to the other path. In case there is no path, how many retries should be done. User friendly names, no. Now the other part is for blacklist. We need to blacklist certain nodes. Right now our device is VD something something on which the operating system has been installed. Fdisk minus L dev SDA, oh sorry, VDA. And here we can see that this is the device on which operating system is installed. So let's blacklist it for the multipath, and these are the default row RAM loop devices for which multipathing should never be created. So we are done. Mode probe dm multipath slash etc init.d multipath d start and chk config multipath d on multipath ll to display the multipaths that are visible to it. So there are two paths, SDA and SDB, to the same LUN, the ID of which is this one. So our configuration is working fine. Multipath.conf, we can say we can copy the same to node 11. SCP, okay, command is not there. Let's install OpenSSH clients yum install OpenSSH clients. Now let us copy the multipath.conf to all other nodes. Okay, copied. Mode probe dm multipath slash etc init.d multipath d start chk config multipath d on and multipath ll. So perfect. The name of the device is also going to be the same because we are using the ID, the SCSI ID of the LUN. So it's going to be same. So perfect. Till now we have a storage device which is ready and which can access your SAN which is present on the base machine through two network interfaces 10.0.2.x and 3.x. So multipathing has been configured, the SAN device is accessible. Now the other part that we need to do is we need to fdisk dev mapper print. There is no such there is no partition inside it. Let's create a new partition. Primary number 1, start with 1, provided the size 250 MB, that is going to be more than sufficient for us. Write it, and now fdisk -l, you can see a partition but that is not yet visible in dev mapper iat. So to get it visible, let's just type the command part probe. Okay, it's not there. Yum search part probe. These are okay. Now we part probe. So I've forgotten the name corresponding to it. So let's do one thing. Install yum utils and fetch it out from the yum repository. Repo query -f star part probe. So what this command is going to do is it is going to fetch out the details from the repository that have been present on the server, and will try to fetch out which is the package that is responsible for providing the file, which is something like part probe. So I think parted is not installed. Let's install it. parted. Let's install it on the other node also. Okay, now if I type tab, I cannot see partition 1, which should be like P1 at the end. So I will just scan the partition table once again with part probe, and now I should be able to see one more partition inside it, which is P1. Okay, fdisk -l dev mapper. Here we can see that the file system or the new partition has been created, but it's not yet visible at the dev mapper. So let's do one thing. Let's run part probe over here also. Okay, so partition 1 is available here also. So what we have done is we have created one partition inside the LUN which is exported by the SAN server. Now the next part that we have to do is we have to mkfs.ext for dev mapper. So this first partition we are going to format it with the file system of ext4 extended for file system. Perfect. Let's make sure whether it's mounted, whether it's mountable or not. Dev mapper /mnt ll/mnt. Yes, it can be mounted, so it's fine. Let's just unmount it. Okay, now what we have to do is shared storage is now ready. What we have to do is we have to set up a high availability cluster for Apache. So Apache should be present on all the clustered nodes. Sorry, HTTPD. So fine, Apache has been installed. Make sure that you are not switching on Apache. It should be switched off because cluster is going to take care of it. Okay, now we have the base requirements ready, but before we start up with it, the management interface should have a package Luci installed on it. That's why I named the host as Luci. Okay, mount dev cd-rom to media. So Luci is a set of packages. The web interface is actually created on the Python language. So let it install. And if we are talking about the clustered nodes, so Luci package requires Ricky to be present on the clustered nodes. So Luci is going to interact with Ricky to update the configuration on the clustered nodes. So let's install Ricky on both these nodes. So Ricky is installed. Let's switch it on. init.d Ricky start chk config Ricky on. Slash etc init.d Ricky start and chk config Ricky on. Now we are waiting for Luci installation to complete. Okay, it's completed. Slash etc init.d Luci start and chk config Luci on. Now Luci works on port 8084 by default. I need to open it from the interface, or I need to open it for the desktops, laptops from which I am going to access this Luci web interface. -I input minus S192 168.1.0/24 minus P TCP minus D port 8084 minus J accept. Fine. And service IP tables save. So I should be able to access https luci.labs.local. Certificate warning because it's a self-signed certificate. Now to log in into it, you can use the credentials of the root. It says you should be familiar to handle it. You should have the concepts clear for Red Hat Cluster Suite before you start working on it. So here is the web interface that is provided by Luci. You can use it to create a cluster, to add nodes to the cluster, and to remove a node from a cluster. Okay, so first thing, how is it going to interact with node 10 and node 11? Initially, when you are creating the cluster, it needs to coordinate with node 10 and node 11 over SSH using the user Ricky. So let me just change the password for Ricky. Ricky123. Ricky123. Password Ricky. Ricky123. Ricky123. So node 10 and node 11 are now ready to interact with Luci. Now what Luci is going to do when you are creating a cluster, it is going to install some packages on them. First it will log in through SSH, will install some packages and configure the clustering between these two nodes. So if you are talking about the interaction between these two nodes, we need to open the ports. Okay, one is the port that we need to open for Luci, which is 11111. So Ricky is using this port. It should be opened -I input minus S 192.168.1.15, which is corresponding to Luci, minus P TCP minus D port 111111 minus J accept. Fine. The same rule is to be created on node 11. -I input minus P TCP minus D port 111111 minus S 192.168.1.15 minus J accept. Oh, what is my mistake? Minus P TCP minus D port minus S 192.168 Sorry, it should be minus ptcp. Okay, so I am allowing access to Luci, which is present on 192.168.1.50. Now you need to know the ports corresponding to the services that we are going to open. The port corresponding to messaging service corosync should be there between, should be opened between node 10 and node 11. Lock D port should be opened between them. And similarly, if you are talking about the interaction between these nodes, it would be a kind of multicasting traffic that will be sent. So right now, let's stop the IP tables and we can talk about it later. Slash etc init.d IP tables stop, IP6 tables stop, and chk config IP tables of IP6 tables off. Okay, so and etc init.d IP6 tables stop. The other reason why we want to switch it off when we are creating the cluster is that in case we are creating it through a GUI, as soon as the clusters will be joining nodes and they are going to create a cluster and interact with each other, in case there is some rule which is not working, so the UI may not be able to create a cluster for that. So let's create the cluster. We can think about the firewall rules later on. Now we are on the Luci interface. We have logged in using a root user. Let's create a cluster and provide it the name my cluster. It can be any name which you think is good. Node name, node 10. Use the same password for all nodes. Ricky123. Add another node, node 11. And Ricky port is the default one, 11111. Now we have some more options. One is say download packages. If required, download the packages on node 10 and node 11. Reboot the nodes before joining the cluster and enable the shared storage support on them. Now tail -f var log secure and var log messages to see what actually will happen. Tail -f var log messages and var log secure. As soon as you click it, you can see it's trying to install the required packages, the library packages, OpenAIS, and all the requirements of the cluster. TLS based support. So what it's going to do is it is going to log in into these two nodes, node 10 and node 11, using the Ricky user and the password that we sent for that we set for that user, and will then install the packages whichever are required. After the packages have been installed, it's going to reboot the machine before they join the cluster. So actually before the installation of this, we installed the bare minimum packages that were required for these nodes. It's going to take some time. Hardware abstraction layer. Mhm. Fence agent for fencing. LVM2 cluster to support clustered LVM. Support for GFS. It's installing these because we selected the option for shared storage also. RG manager, which is responsible for relocation of the services from one clustered node to another. CMAN is the basic cluster manager which should be running on any clustered node. So node 11 has already been kicked to reboot after the installation of the packages. So yeah, it has started rebooting. Coming on to node 10, yes, it has also been initiated to reboot. Let's wait till they come back. Okay, let me create the SSH connections with these two nodes. Not yet up. Status of 11. Not yet up. Yeah, it's up now. Make sure that IP tables is not working. Yeah, IP tables, it doesn't have anything. So the interaction would be fine. Tail minus f var log messages. Okay, so creating cluster node 10 and enabling services. So it's still working on it. Cat slash etc cluster.conf. So here you can see that the basic cluster configuration file has been created by this Luci web interface. If you try to understand, the config version is 1. Every time you modify this file, you need to increase the version of config by 1. This is the name of the cluster, which is my cluster, and the format is going to be, it's an XML file. The other part says cluster nodes from here till here. So how many cluster nodes do we have in it? One is node 10, node ID 1, and other is node 11, ID 2. Expected votes 1 and 2 node is 1. If you are talking about 2 node cluster, there could be a situation of split brain. So to prevent this, we make use of two node cluster equal to 1, because if both the nodes contribute as a single node to the cluster, so 1 plus 1, it's 2 in case both of them are up. In case one of them is disconnected, it will show you node 1. So just to prevent the split brain and the race between them, we specify this option 2 node. Fence devices have not yet been added. So after it has been set up, okay, here we can see my cluster. Node 10 is now a part of cluster, but node 11 is not, due to some reason. Let's see what the reason is. /etc init.d cman status. So CoroSync is stopped and your cluster manager is not running. /etc cluster.conf node 11 /etc cluster. Okay, just before typing it, /etc cluster, and there is no cluster.conf present on it. So let's manually copy it. It's now there. Now we try to start cluster cman service on it. chk config --list cman. Let's switch it on. chk config --list cman. So as soon as you start the service cman, cluster will come to know that both the nodes are now a part of a cluster and the cluster name is my cluster. So this is the basic service that must be running on every clustered node. It checks out whether the network manager is running or not. If you are talking about the cluster nodes, network manager service should not be running. Global setup, check out for the kernel modules. If required, it loads them. Checks out for config.fs, waiting for quorum. Starting fence D. Fence D, as we already discussed, is an application or the daemon that runs on the clustered nodes and take care of fencing a device in case it's not responding. This is distributed lock management, and this is for GFS, global file system. Okay, so we can see both the nodes. The next part is to add resources to these clustered nodes. Our objective is to create a clustered web service. So we are talking about the floating IP address, and let me see, ping www.labs.local. So effectively we are going to call the web service by www.labs.local, which is going to point to 192.168.1.200. Right now it's not assigned to anyone, but after the cluster has been created, it is going to be a floating IP address which is going to be assigned to the device which will be active. So let's add certain resources to your cluster. First is IP address 192.168.1.200. Netmask, if you want, you can create it 24, the same as the other interface, or you can leave it. Monitor the link. Fine, let others be the default. Number of seconds to sleep after removing IP address. Add another resource which is going to be a file system, because if you are talking about the Apache web cluster, so first thing is we are going to call it by a name or IP address. Secondly, there should be some shared folder in the SAN which is going to be mounted on the node whichever is active, and that particular file or that particular folder is going to have the complete document root inside it. Okay, so let's add the device dev mapper p1. So this is the device. The name, you can give it any name. Let's say it's webroot. File system, it's extended for. Mount point, where it's to be mounted, where www html. The device dev mapper iet, this is the first partition p1. Mount options not required. File system id not required. If in case it's not able to mount safely, force unmount. Force fsck and use quick status checks. Reboot host node if unmount fails. Submit. Because the same shared folder should not be accessible by multiple clustered nodes. And the final thing is the service that needs to be restarted on the node which will be active. So this will actually be your script httpd /etc init.d httpd. I submit it. Now we have all the three resources which are required to create high availability web service. Now there is one more option which is failover domain, which says where should the service be relocated to. Let's give it the name prefer node 11. Prioritize means order the nodes to which server failovers. Priority, we can set the priority of them. Let's set it 10 for node 10 and 11 for node 11. So 11 is greater than 10, so node 11 has higher priority till the time node 1 is available. Node 11 is available, the web service is going to run on node 11. Restricted, in case we have more than 2 nodes inside it, maybe 4 or 5 nodes, in that case we can select only a few of the nodes and service will be failing over between those nodes rather than going out of those nodes. For example, we have 5 nodes inside the cluster and we are selecting only 2 nodes for this failover domain. By default it can fail out to the node 13 or 14 also, but in case we are going to restrict it, it is not going to run out of any of these clustered nodes. No failback. By default it failback, which says if node 11 goes down, service will be relocated to node 10. After node 11 is up again, the service will be failed back to node 11. That is, it will start running on node 11. No failback says even in case the server is back, let's continue to run on node 10. So do not send service back to the first priority node when it becomes available again. And here we select which all nodes should be the part of this failover domain. It could be a subset of your nodes. Right now we only have 2 nodes, so let's select them. Fine. Now there is one more option of fence devices. Okay, fencing is actually the disconnection of your virtual machine or disconnection of your clustered node from the SAN storage. We can make use of APC power switch, which says and in which you will specify the credentials that will be used to log in into this APC switch and to send a reboot signal to that server. Actually be a hard reboot. The same happens using SNMP interface, Brocade fiber switch, Cisco. So the DRAC is supported. You'll provide the credentials, and DRAC will be used to reboot the node which is not responding. HP ILO is supported, but in our environment, RHEVM fencing is also supported. So what we are going to use is for KVM, which is fence vert in multicasting mode. What is the name that you want to give it? So KVM fencing. Let's say it could be any name. Okay. Now coming on to the nodes. Okay, fencing is the part. Okay, let's add them. Node 10. Let's attach the fencing devices to the nodes now. After selecting node 10, I am going to add a fencing method. Give it any name, doesn't matter. Add the fence instance. It's going to be KVM fencing. And in case you are doing KVM fencing, how should it be fenced? This is node 10, so specify node 10 over here. In case we want to fence node 10, it will be a kind of command which is going to fence node 10. So this part is done. Let's add fencing to node 11 also. Fencing method. Add fencing instance, it's KVM fencing, and the name of the node. Actually this node 11 should be the same as it's displayed in VirShell list. So they are actually node 10 and node 11. Now, how does this fencing works? There is some application that must be running on the base machine that is used by these clustered nodes to fence the other node. So there should be some service which should be running on the base machine also. So that is uh, one moment. Grep minus I fence. So the name is like fence vert D. Fence vert D and fence vert D multicast should be present on it because we are going to make use of multicasting to interact with the fence D service which is running on the base machine, which will be used by a node to connect to it and then kick off the other node. So okay, fence vert D minus minus help. Let's go into the configuration mode to configure it. Start from scratch, yes. So this is the thing that we are doing on the base machine on which KVM is installed. So start from scratch, yes. The module search path, let it be default. Now it shows you that it has the backends available as libvirt and checkpoint. We are going to use libvirt. Available listeners are only one, multicasting. So we are going to use multicasting, which is the default. IP address, if you want, you can change it. Default works fine for me. Multicast port, let it be default. The interface on which it should listen. So this should be the interface which is used to interact with node 10 and node 11, and we are using the interface BR0, which is on network 192.168.1.0. So if config BR0, just to confirm, yes, it's the same. So I'll make use of BR0. Key file, yes, the default is fine, it's already created. If it's not created, it can create it, or you can use EFIF commands to create a file of size around 4K. Backend module, the only option is libvirt, so select it. Libvirt URI, QEMU system, fine. So should it be replacing etc fansword.conf? Type yes. And now let's start the service. Fansworthy is stopped. Start and chk config fansworthy on. Actually it's underscore. So the service is switched on. Now, while configuring, you came to know that there is a key file that is used to interact with the nodes. So we need to copy this file to the same location on node 10 and 11 that will be interacting with the base machine to reboot the other node. So let's copy it /etc cluster fansxvm key, copy it to node 10 /etc cluster, copy it to node 11. Now your fencing should be ready. If you want to confirm whether you can fence the other node or not, let's use the command to fence it. Fence underscore xvm -h. Here you can specify the command or vam/etc cluster cluster.conf. Here you should be able to see the details of fencing. Fence method is method1, which says domain is node 11. KVM fencing, what is KVM fencing? KVM fencing says it's going to use the agent fence xvm. So the command is going to be fence underscore xvm --help -h is for domain. So let's use it. -h, I'm going to fence node 11 while sitting on node 10. Coming on to node 11, and here you can see that it's just kicked to reboot. So this thing, assure yourself that your fencing is working fine. So let the machine boot up, and other thing that you could see is it was a kind of hard reboot. So it was just it's known as Toneth. Shoot the other node on the head. So let it boot up. In the meantime, if you type the command clu stat, you can see that node 11 is now offline. Let it come online and we'll continue with our discussion on the cluster. So it's now online. Okay, if you are talking about the high availability cluster, so you should have RG manager running on it /etc init.d or let's see whether the application can take care of it. We have added two nodes in the cluster. We have added fencing to the devices. We have created a failover domain. We have added three resources: IP address, file system, and the service groups. Okay, before we set up the clustered service, let's make sure whether it works fine. Theoretically, how it's going to work is mount dev mapper var dev html, fine, and then it is going to assign it an IP address init.d httpd restart or start, you may say. It failed to start and it said document root must be directory. So it's actually an issue associated with the SC Linux. Details of it: ls minus lz var dev html. So it's not actually making use of httpd sys content. So let me restore con minus r for var dev html, and let's also create a file var dev html index dot html inside it, which will nothing have not, which will have nothing else except clustered web service or whatever you want to write, clustered web server, and restore con. If you see the syntax, so it's httpd sys content now, so it's fine. Now your Apache should be able to restart successfully. Perfect. Now let's stop Apache and umount var dev html. Fine. Make sure that Apache as a service should not be started on any of the clustered nodes. It should not be switched on because the cluster itself is going to take care of it. CLU SVC ADM minus L resource groups lock. Okay, and minus U is to unlock. Okay, so CLU SVC cluster services management. This is the cluster services management interface. Okay, so let us create the first clustered service, which is my web cluster or something like that. Add service group to the cluster. So my web cluster. Automatically start the service? Yes. Run exclusively means if we are talking about any of the clustered nodes, it should be running only one clustered service. For example, we are running multiple clustered service on the same cluster. It could be clustered bind, it could be clustered MySQL, and MySQL clustered web cluster. So in case you mark it as exclusive, on one node there should only be my web cluster running on it. There should be no other clustered service running on it. Failover domain, by default it's none, means it can failover using any of the policies to any of the servers. If you select prefer node 1, sorry, node 11, so the service will prefer to be started on node 11. Recovery policy, relocate to the other node, click on submit. So as soon as you submit it, let's see what actually happens. Okay, CLU stat, it says RG Manager is now running on node 10 and the services started on node 10. Okay. /etc init.d. RG Manager is the service which is responsible for relocation of the service, and it's not running. That was the reason it was not started. Start and chkconfig RG Manager on. So CLU SVC ADM is the command line utility that you can use to migrate a service from one node to another. Let's see whether the migration right now. Here you can see that node 10 RG Manager is running and node 11 also RG Manager is running. Okay. Now let's see what happens if this machine goes down or reboots. Or before that, let's have a look into the web server. Okay. We created a service, that is fine. But did we attach any kind of resources to it? No. So let's add resources to it. That's why it's not doing anything. Let's add a resource IP address, add a resource web root, and finally start web service. So we are using three resources. The shared IP address should be assigned to the one node which becomes active. That node should be able to mount this document root, and that node should be able to start Apache. Click on submit. So here you can see that Apache is now running, and here you can see the clustered web service. Now what happens if this node is not accessible or this node reboots? Till now it was running on node 10, and let's have a look into CLU stat on node 11. Here you can see that it's stopping on node 10 and it's now starting on node 11, and it's started. So even if one of your node goes down, your service is still present on the other node. If you try to refresh it, Control R, you can confirm the same using curl http www.labs.local, and here you can see that it's still accessible and it's the same document root and the same data that you placed, because you are using the same shared SAN in both the cases. df-h says this is mounted. Now let's wait for node 10 to become active. That's still offline. Node 10, yeah, it's close to. So now it's up, but I still can't see RG Manager inside it. Yeah, RG Manager is started. And let me try to log in through SSH. I can log in into it. And here, using the clu stat command, you can see that the cluster is up and the services are running on node 11. If you type df-h, you cannot see that the SAN partition is mounted. So SAN partition is not mounted. If you see to the status of HTTPD service, it's not running. And if you see IP-addr show, you don't have 192.168.1.100 assigned to it. So all these three things are assigned to the node 11 on which the clustered service group is running. So IP-addr show says a virtual IP address 192.168.1.100 is assigned to it. etc init.d httpd status says http is running, and df-h says your SAN partition is mounted. Okay. Now, what happens when the Ethernet interface of the node 11 goes down or disconnected due to any reason? Actually, you will be having bonding behind it, but we are considering about the scenario what happens when the node 11 is not able to send the messages to node 10. So I'm just bringing down the interface. We are on node 11. Here we type the command clu stat. So it has not yet identified that node 10. Okay, so here you can see that the services have been migrated to node 10, and uh, the status of node 11 is, because it was not able to interact with node 10 on the cluster, no messages were received from node 11. So finally the cluster fenced node 11, and finally you can see that your node 11 is now rebooting. So this is how, and here it says node 11 is still offline. So as soon as node 11 will come up, it will become a part of a cluster, and finally you can now migrate your services from one cluster node to another, and this is how it works. So let me see if we have missed something in the generic part. Okay, so this is how the generic web server based cluster is created. Right, I'll see if we are missing something and we'll create one more video for the same. I'll be waiting for your reviews and for your comments so that we can have some more videos on it. So thanks for viewing the video. Have a good day.